All right. Today we're going to talk about derivatives of inverse functions, or mostly evaluating derivatives on inverse functions. So I got here on Desmos. I have the function x squared plus one. Now, x squared plus one. These aren't for 0 is greater than or equal, is less than or equal to x. These two functions here are going to be inverses. So we'd have this going on. Now these 2 points, if you don't remember what happens with inverses? Okay, with inverses, the x and the y trade places, and you can see that with the coordinates. We had 2, 5 that switches to 5, 2. Now, what ends up happening is we could take a look at these points and we can say, oh, wait a minute, okay, well right here, this one's increasing going on right there, and I could probably find out what the derivative is, and it wouldn't be that hard to take the derivative x squared plus x squared plus 1, and take the derivative, get 2x, and so obviously the slope here is going to be 4. But what about this one? Is there some sort of relationship there? Because there is symmetry that's going on here, and the idea is that this symmetry, as it folds over the line, actually the line is y equals x, is the line of symmetry, y equals x. That line, you can see everything flips over right over that line. And so if this has a slope of one thing and flip it over, then there's going to be some sort of relationship with it. And so right here, I put these two equations. So f of x equals x squared plus 1, and g of x is radical x minus 1. And so, okay. And well, f of 2 is 5. And then just to prove that their inverse is f, g of 5 is 2. And so you can see, that's how we get those points. So f prime of 2 is 4. We just talked about that. Now, because that's this point. Now, the corresponding point, let's talk about the corresponding point. Okay, so that we're talking about at 5 now. So g prime of 5 is 0.25, or better yet, 1/4. So what's that relation between this one and this one? They're inverses. I mean, not inverses, they're reciprocals. So, all right. So with this, we're going to have, this is what the sort of thing that we're going to be using. We're going to be holding on to this idea of what's going on there. Now, I'll kind of walk you through what that is. All right, so let's take a look at how we would go about handling this for the derivatives of inverses. All right, so you're going to be given a function. So you're going to be given y equals a function of x. All right, so you have that. Now, you'll also be told something that, you might be told that g is the inverse of f. Okay, so g is the inverse of f. Okay, well, with that, then what we'd have is real, basic. Okay, really what this means is what that means is that, let's say, if f of a equals b, okay, so f of a equals b, which means the coordinate a comma b, then g of what? What equation would we write? We'd write g of b equals a, because that means b comma a. What we can go from here now is we can say that g prime of b is going to be 1 over f prime of a. This is what we just did. This is just what we just looked at. All right, so that's really what's going on. So we gotta kind of go through this and like, okay, well, great. Well, how would we do something like that? All right, well, let's start with that first one we have. F of x equals x squared plus 1. All right, we'll be told, so you again, given f of x equals that, and g of x equals f inverse of x. So f is g is an inverse function of f. Find g prime of 5 is what you're going to be told. G prime of 5. So here's the process. First, we start here and we say, okay, well, this means b equals 5. B equals 5. Remember? We had that. This is G prime of B. Now B is 5. So need to find A. Okay, so then we know that f of A equals B. So we say, okay, well, f of A, so we have A squared plus 1, so that's f of A equals B. So A squared plus 1 equals B. So A squared equals 4, and A equals 2. So we need to find that. Okay? Then we write G prime of 5 equals 1 over f prime of 2. So we're going to need f prime of x, which was 2x. Take the derivative of that, 2x. So that means this would be 1 over 2 times 2, which is 1 over 4, which is exactly what we got. And so this is the process. All right, so let's take a look at some other examples. Here's a review book here, okay? This is a little bit more complicated one. All right, so we have this. Y equals f of x, which equals 2x cubed minus 3x. If h of x is the inverse function of f, then h prime of negative 1 equals what? All right. So again, we're going to go through that process. All right, so number one, or step, all right, let's go, step A. All right, step A. We have to find the coordinate. All right, we were told here, okay, we want h of negative 1 if f of x equals 2x cubed minus 3x. All right, so we have f of x equals 2x cubed minus 3x. All right, and we want to find h prime of negative 1. So remember, so again, on on F, this is a y value. So that's the key. And remember that this is a y value. So it means we'd have negative 1 equals 2x cubed minus 3x. All right, and so we have to solve this for x. Now this isn't as straightforward necessarily as you'd realize, but it's 3x plus 1. Okay. However, they're going to make them, if you could use a calculator and solve for it, but there's a good chance that we're going to give you something that's going to be pretty easy. And if you just look at this real quick, you can see, it doesn't take long to see, x equals 1 is a solution. Because 2 times 1 cubed minus 3 times 1 plus 1. So that's going to be 2 minus 3, which is negative 1 plus 1. That equals 0. All right, so this coordinate, we're going to find that coordinate. So the f coordinate, is 1, negative 1. The h coordinate is negative 1, comma 1 is what we end up with. All right, so if we want then, all right, so then B, second step, so we get the number A, find the coordinate. B, we need f prime of x. F prime of x, well, if we had 2x cubed minus 3x, that's going to be 6x squared minus 3. All right, and then we're going to do f prime of 1. So we're going to have 6 times 1 squared minus 3, which gives us 3. And then, finally, h prime of negative 1 then equals 1 over f prime of 1. So we have 1 over 3. And this is the process we want to go through. All right, so here. So this one's got a bit, kind of a big problem, but again, we're gonna do what we can, usually to make it work out to a pretty easy one. So I want you to try this, and the ones we're going to do are going to be a lot simpler than this mess. So if you can do this one, then you can do the other ones. All right. So now, okay. All right. Hopefully, pause it, try it. Okay. So let's go through them. 3 special steps. That's all that you need. 3 special steps, and you'll succeed. Special assignment starting now. 3 special steps will show you how. Step 1, find the coordinate. Okay, well, we're told g prime of 5. We want g prime of 5. So that means that this is a y coordinate for this one. So we say 5 equals x cubed minus 3x squared plus 8x plus 5. What am I going to do? Well, I'm going to subtract 5 from both sides because I got to make this equal 0. So x cubed minus 3x squared plus 8x. Oh, wait a minute. I can factor that. It's going to be x. Then I'm going to have x squared minus 3x plus 8. Well, this is unfactorable. So x equals 0. So that means our coordinate for f, our f coordinate is going to be 0, 5. Our g coordinate then is 5, 0. All right, so now we need f prime of x. All right, so I got 3x squared minus 6x plus 8. F prime of 0 then is, well, that's pretty easy. That's 8. And so then g prime of 5, we're going to take that, and g prime of 5 will be 1 over 8. Boom! B. So this is the idea. How we want to go about doing this. We got some different ones that pop up. So in the work, give them a try and see what you can come up with. All right. And let me know if there's any confusion.